In this video, we'll be talking about first-order linear differential equations. So, first let's talk about the standard form. So the standard form of a first differential equation is dy over dx plus px times y is equal to q of x. If equation is not in this form, you must rewrite it to be in this form. So, a tip is that if there is a coefficient in front of dy dx, like x or x squared, you must divide by that term because you just want to get px alone. So now you're integrating, this is your standard form. Might as well box this and then we'll make a note for each of these. So now we have our integrating factor. You need to know this as well. So this is going to be mu times x is equal to e to the integral of p of x times d of x. And this is a fundamental property. After multiplying both sides by mu of x, multiply both sides, then the left side becomes dx after. Oh, this is for the wrong thing. Okay, you don't have to, for this, you don't have to, don't add plus c constant of integration because it cancels out. Now the product rule tricked for this. Now let's say that we multiply the entire equation. Let's say that we have the equation from above, mu x times dy over dx plus mu x p of x times y, and this is going to be equal to mu x q of x. So then this becomes d over d of x mu x times y is equal to mu of x times q of x. Now, this is a fundamental property of the integrating factor, is that its derivative is mu x times p of x, because this collapses into a single easily integratable derivative. So now make sure you add plus c before you divide by mu x. Otherwise, your general solution will be wrong. So now let's move on with notes for the initial condition. So for the initial condition, we have y of x initial is equal to y initial. So for this, you plug in after solving, and then you solve for c, your constant of integration. Now, let's explain some of the concepts. What exactly does linear mean? So linear means that, so for the requirement, it's for a first order to be, for a differential equation to be first order and linear, is y and dy over dx appear only to first power, so they're only raised to the power of 1, and also there are no products like y squared, y to the dy over dx, and also sine of x. So this means that linear would be this, dy over dx plus xy is equal to x squared, and then not linear would be dy over dx plus y squared is equal to x. So now the reason why the integrating factor, why the integrating factor works is because it forces the left side to become d over dx times mu y. So essentially you need to know that linear differential equations are not separable, but they become exact derivatives. After multiplying by mu of x. So some things that you need to know are that, things you need to remember is that for recognition, your equation must be in standard form. Also remember that p of x depends only on x, and q of x also depends only on x as well. And also remember, you always have to multiply each term by mu of x, and also compute mu of x correctly. Also remember your parentheses when integrating, and don't solve for y too early. Also, so in general, remember that solutions, they involve exponentials. And remember, you always need to do the integrating factor, and initial conditions, it's right here. Initial conditions are after integration. So now let's move on to some examples. Let's say that we have a basic linear like dy over dx plus 2y is equal to e to the power of x. So now our first step is going to be you have to identify p of x. So here we can clearly see that p of x is going to equal to 2. And now we have to apply the integrating factor. The integrating factor is going to, is mu of x is going to equal to e to the integral of 2 dx. That's just going to be equal to e to the 2x. As you can see, our integrating factor is this right here. And we have we plugged in p of x, and then we plugged in, let's see. So you can see this is p of x, and we plugged in p of x right here. We identified p of x. So now after this, we can multiply the next step. Multiply our entire equation, and we have, let's move this so that everything is like, it's kind of a little messy right now. So we can multiply both sides by dy dx plus 2e to the 2x y. This simplifies to e 3x e to the 2x. Now we can rewrite this as a derivative. So in doing this, we get d over dx is equal to e to the 2x times y is equal to e to the 3x. Now after this, we can integrate. Integrating this, we get e to the 2x y. This is just equal to, now integrating, we do that. That's going to be integral of e to the 3x times dx, and this is going to be 1 over 3 e to the 3x plus c. So then rewriting all this, we have to solve for y now. Solving for y, we get that y is equal to 1 over 3 e to the x plus constant of integration e to the negative 2x. So this is our answer. Now we can move on to our second problem. So for this problem, let's say that we have this over here, dy over dx minus 1 over x times y is going to be equal to x squared. And let's say that we have the initial condition y of 1 is equal to 2. So this is a problem with an initial condition. Okay. So let's start off with our first problem. These are generally just gonna follow this process. So for our p of x, we can identify that p of x is going to equal to negative 1 over x. And then now we can have our integrating factor of mu of x is equal to e to the power of 1 over, negative 1 over x times d of x. And this is going to be equal to e to the negative ln, absolute value of x. And then this is just equal to 1 over x because this is just e, and you flip it because of the negative exponent. So now we can multiply the entire equation. So we have 1 over x times dy over dx minus 1 over x squared times y is equal to x. Now we can rewrite this as a derivative. So we have d over dx times y over x, and that's going to be equal to x. Now integrating this, we get y over x is equal to x squared over 2 plus c. Now if we solve for y, this is the last step, then we get y is equal to x to the 3 over 2 plus cx. We multiplied everything by x here. Then that canceled. Constant of integration of x. And now we have the initial condition. So we have to apply the initial condition. So applying the initial condition, we have the initial condition of y of 1 is equal to 2. So that means that we have the input and we had to plug in that. So we have 2 is equal to 1/2. So this so x was equal to, let's make this a little clearer. That was that, so you just plug that in there, and then you have 2, right? So that's like the entire thing, so that's y. So then you add plus cx, and we're solving for the reason being we want to get c. So after this we get c is equal to 3 over 2. So now we can rewrite the entire equation as y is equal to x to the 3 divided by 2 plus 3 over 2 times x. And then that's our final answer. So now let's do a third problem. So let's say that we have, again, it's the same process. So it's gonna be, so we have x times dy over dx plus y is equal to x squared. And this, we were given the initial condition of y of 1 is equal to 0, so that's going to be y of x equal to 0. So now first we had to put it into standard form, because it's actually not in standard form. So putting this in standard form, do we get dy over dx plus 1 over x, y is equal to x. Now we can skip. Okay, now we can do the integrating factor. So we have mu of x is equal to e to the integral of 1 over x times dx, and that's going to equal to x. So now we can multiply the entire equation. So we have x dy over dx plus y is equal to x squared. And now we can rewrite this as a derivative. So we have d over dx times xy is equal to x squared. Now integrating this, we get that xy is equal to x to the 3 over 3 plus c. Now if we solve this for y, we get y is equal to x to the 3 over 3 plus c over x. When we divided everything by x. Now after this, we had to apply the initial condition. So we have 0 is equal to 1 over 3 plus c. Then we have c is equal to negative 1 over 3. So now we can rewrite the entire equation as y equals to x squared over 3, plugging in c is negative 1 over 3x. And that is it for